Awesome. Okay, hi everyone. Happy Monday. Um, I'm Isla. I'm going to be teaching you about if statements, for loops, and while loops today. Let's see. Okay, awesome. So some announcements before we start. The first homework is due on Wednesday. There's a resource notebook available. My office hours are actually like right after this lecture. So if you're having any trouble like opening the notebook, or if you have any questions about the homework, feel free to stick around after lecture. And I'll be here to answer any questions. Oops. Huh, okay. um, Sorry, 1 second. I don't know what happened. Okay, there we go. Awesome. Okay, yeah, here's the attendance form that's sent in the chat, and the office hours are scheduled. So again, like mine are right after this lecture. Everyone else's office hours can be found on the B courses. So check that out if you need help with the homework or have any other questions or anything like that. So a quick recap of what we've done.
I went to
Oh,
I went to office hours on Friday, but nobody was there. Are they supposed to not start until like next week or something?
yeah, so they're going to be starting this week. So like my office hours today are going to be like the first office hours. Yeah.
All right, thank you.
Yeah, sorry about that though. Okay, awesome. Any other questions about those logistics? Okay, cool. So quick recap of what we did last week. We went over some of the data types, so integers, floats, strings, lists, dictionaries, tuples, and Booleans. We're going to be going more into depth about like Boolean values today. Also functions. How do you write a function and how do you call a function? And then the last thing we went over is variable scope. So like what's the difference between setting a variable within a function versus outside of a function. Some important things to keep in mind about what we've already went over is that our code can't make like judgments. It can't change the flow of the code according to like the inputs or variables. So let's say we define a function and it takes in an integer. If we give it a string value, our code's just going to error. Like it doesn't know how to deal with a string value if we write it to deal with integers. So that's just like something to keep in mind, is that the different types of values are like really important when writing code. So here are some Boolean operations. The ones that I want you to focus on right now are circled in red. The first box I just wanted to highlight because these operations are like really weird and I don't really use them. I don't think most people don't really use them, but they kind of are similar to like normally used operations. So I just wanted to call them out. Like the ampersand, which, is and, is not the normal and, it doesn't work the same. And the caret is not the normal exponent, right? Because we use the 2 asterisks for exponent. So just some things to keep in mind. These bottom 2 boxes are what we're going to be focusing on right now for dealing with Booleans. So we have greater than, less than, greater than or equal to. These double equal signs is equal to. This exclamation point and equal sign is not equal to. And then we have these 2 things down here, and or. And these are a little bit funny, so I'm going to go into more depth about those. Here on the side, I just have how these statements are formatted. So you have a statement, then you have and and then another statement. And this is going to return either a true or false value. So this is a little bit abstract, but we're going to be going into examples that I think will make it a lot clearer. So just some definitions for and statements. It'll return true if both values are true, if both statements in the and statement are true. And it'll return false if one of the 2 values is false. Then for or, it'll return true if one of the two values is true, and it'll return false if both of the values are false. I know that's like a little bit confusing and abstract, so we'll do some examples, but does anyone have any questions about this so far? Awesome. Okay. Yeah, so let's do some examples, again, because that's like kind of confusing. So I just want to go through these all together, so feel free to call it out, or if you're not comfortable with that, feel free to message it in the chat. The first one, true and true. Do we think this is going to return a true value or a false value? True and true. True or false? Yeah, so this is the first one, so I'll just, I'll tell you what this one is. It's true, right? Because both of the statements in this first one are true. So it will turn a true value. Yeah, awesome, true. The second one, true or false. Is this going to return true or false when we run this in Python? Yeah, awesome. So this is going, or sorry. So actually this is going to return true because or statements, it only needs one of the values to be true. Oops. One of the values to be true to return true. So it's a little bit confusing. Yeah, and then this next one, 1 is greater than or equal to 2. Yeah, exactly. This is going to be false. Yeah. Because 1 is not greater than or equal to 2. This fourth one is kind of just like a throwback to last week about what this, percent symbol does. So 5 modulo 2 is equal to 1. What do we think that is? So the modulo does like the remainder of 5 divided by 2. Yeah, so the remainder, if you divide 5 by 2, is 1. So that's a true value. So this next one, 2 is not equal to 2, or 1 is equal to 1. What do we think? Yeah, so this is true. So we have the first one is not true, right? Because 2 is equal to 2. But the second one is true. And the or statement is going to return true if one of the statements is true. So perfect. This next one is the same as before, except we don't have the parentheses. Any guesses on what that's going to do? Is it going to change anything? Yeah, this one's a little bit tricky. I didn't really go over this, but actually this is the same. Even without the parentheses, it still runs the same. It's still going to return true. Okay, this next one is kind of a trick question. I just want to preface it with that. 3 over 0 or true? What do we think this is going to return? Again, this is kind of a trick one, but yeah. So this one's interesting. You would think it would return true, right? Because one of these statements is true, and that's what or will return. But actually, 3 over 0 gives an error when we run it in Python. So when we run this statement, it doesn't even get to the true value at the end. It just sees the 3 over 0, and Python will just return an error telling you that you can't divide by 0. So again, like this one's kind of a trick question. It doesn't return true or false. It returns an error. And I just kind of threw this one in there because I think it's interesting to think about how the computer is like reading what you're inputting. Yeah, so it just reads 3 over 0. Python says it can't do that, and it stops there. So along the same vein, what about true or 3 over 0? What do we think we're going to get? True, false, error? Yeah, so for this one, we're going to get true, which is kind of interesting because Python isn't even getting to the second statement. It's seeing this true value and that it's an OR statement and knows that OR statement only needs one true value, so it's returning true. So it's not running 3/0, it's not returning an error. And then this last one is very similar to number 8, false and 3/0. Any ideas? False and 3/0. Yeah, so again, this one's also a tricky one. So this one is not going to return an error because in the same way that the OR statement only needs one true value to return true, this AND statement only needs one false value to return false, right? Because both sides of the AND have to be true. So it sees this false value, it sees and it doesn't run 3/0. So it returns false. These last 3 examples aren't super important. They're kind of just like how the computer's thinking. If you want to learn more about this, take 61A. But I just think it's kind of interesting to think about. And then this last one, we haven't talked about not, but can anyone guess what not 2 = 1 will be? Not 2 = 1. Yeah, so 2 = 1 is false, but we're saying not false, which is true. So I didn't go over that, but see that you guys got it, which is awesome. And again, like all of these aren't super important to know, but I think they're kind of interesting mind exercises to go over. So yeah, any questions about any of these examples that I went over? Okay, cool. So next we're going to get into if statements. Like, why do we care about true or false values? Like, they seem not super important, but they're actually really important for if statements. So let's say if we want to write a piece of code that outputs if the variable is greater than 10. So we want to take in some number and determine whether it's greater than or less than 10. So this flowchart kind of goes through the thinking and the code that we're going to write. We have this input variable x. We compare it to 10. We determine if it's greater than 10. We want to print this statement, x is greater than 10. And if it's not greater than 10, we want to print the statement x is not greater than 10. So how we go about doing that is what's known as an if statement. So this first line, all of it's not super important. It basically, we're defining this variable and having the user input a value. So let's just say, for example, x is 5. How we write an if statement is we say, if x is greater than 10, colon, we start a new line, we tab, and then we do whatever we want it to do. So in this case, print x is greater than 10. Then we start a new line, we write else, colon, print x is not greater than 10. So this is basically saying, if x is greater than 10, do this, but if it's not, do this other thing. So in our case, with x is equal to 5, we run through this first statement. It says x is not greater than 10. So it skips to the else statement and then just prints this statement right here. Any questions about like the format of an if statement? Yeah, feel free to type it in the chat or just call it out. Okay, great. Yeah, something important to note is we want to make sure that the if and the else these two lines are in line with each other. Oh, and this is just a fun little comment that we don't really need an else statement. You can just have an if statement. Um, yeah, but we want to make sure that the if and else lines of code are in line with each other, and then the statements inside them are tabbed in. So that's really important for it to run correctly. Yeah, exactly. Thanks, James, for pointing that out. Yeah, so make sure you're starting new lines and you're tabbing in. All right, so what if we also want to, separate the case where x is equal to 10? So we have the same flowchart as before, except we have this extra branch here that says x is equal to 10. We want to output this print statement, x is equal to 10. So how we go about implementing that, this is the same code as before, except we have this else if statement. So it's written elif x equal sign 10. So kind of same structure as before. Some important notes about this is your computer is going to run through this like top to bottom. So first it's going to check, is x greater than 10? It's going to do this. Then it's going to go to the else if statement. So it's not super important in this example, but it's important to keep in mind how you're ordering your different statements within your if statements. Yeah, and we can also write nested if statements. So if we want to check if x can be divided by 2 and say 3, same code as before, except we have this extra if statement inside our other if statement. So yeah, you can just have nested and nested and nested if statements, which gets confusing fast, but you can definitely do it. But can anyone think of a way that you might go about doing this without writing this as a nested statement? So instead of having these two if statements, does anyone have any ideas of how we could write this so it's only one if statement? Let's see. Yeah, exactly. Yeah, so Derek said using and that's exactly right. We could say x modulo 2 equal sign 0 and x modulo 3 equal sign 0. Oops. And we remember that and make sure that both of the statements are true. So that will satisfy what we're going for right here. So that's exactly right. This one's kind of a challenge, and I'll just let you guys think about this for a little bit. What if we wanted to include all of the different possible scenarios? So if it can be divided by 2 but not 3, if x can be divided by 3 but not 2, or if it can't be divided by 3 nor 2. So I want to give you like a couple moments to kind of think about this. Maybe if you have like a scratch sheet of paper or your terminal open or a Jupyter notebook open, maybe try and to write something that accomplishes these things. Just give you a couple moments to think about that. You don't have to, but just think about it. Make sure it's divided by 2 but not by 3, can be divided by 3 but not by 2, and can't be divided by either. And all this can be accomplished by if statements. Yeah, and while we're all kind of working on this challenge, if anyone has any general questions about if statements or this problem in particular, feel free to let me know. Okay, I know that wasn't a ton of time, and however far you got, that's totally great. I'm gonna go over what what I wrote. Oops, what I wrote. Um, if yours doesn't look exactly the same or anything close to, don't worry about it. Um, I'll just explain what I did. Um, so my first if statement is checking if it can be divided by 2 and 3. If both those are true, I'm printing that it's divisible by 2 and 3. Then I'm checking um, if it's divisible by 2. If that's the case, I'm printing divisible by 2. And then I'm checking if it's divisible by 3. And then my else statement, kind of encompassing the fact that it's not divisible by either of these numbers. Did anyone solve this or think about solving this differently or have any questions about what I did to solve this problem? Okay, awesome. So now we're kind of transition a little from if statements to thinking about something more iterative. So what if we want to run our code, say, n number of times, like 100 times, 10 times, 1,000 times? If statements can't accomplish that. If statements run through your code once, and that's it. So to accomplish something iterative, we have to use something called a for loop. So this little diagram here kind of goes through what your computer does when you write a for loop. It takes in each item of a sequence. If it's not the last item, it'll run the statements within your for loop. And if it is the last if it is the last item, it'll just exit the loop. So here I just have the format of how you write a for loop. You have for item. So the things that are in red are like what you would insert into your code, like your variables, your lists, whatever. For your item in your list, do some statement. So another important thing to note is just like for if statements, you need to have that colon at the end right there, enter, tab, and then your statement within your for loop. So the formatting of this is really important for it to run correctly. So for loops basically iterate over items in a list or a range. So let's say that we want to print numbers from 0 to 100. If we wanted to do this, we could do it by hand, but it would take a really, really long time. But we can write something really simple that'll make our computer do it really, really quickly. So how we do that, this is just a quick example of how a for loop works. For I in range 1 to 101, colon, new line, tab, print I. Some things about this is that I is like very arbitrary. I think I is most commonly used because it's like index or it's short, you know, but you can use anything. You can use for number in range 1 to 101. You can say, you know, for peanut butter in range 1 to 101. Like it can be it can be anything. I mean, it has to be one word, but yeah, it can be anything. And also this whole range thing, it's not including the last value. So it goes from 1 to 101, but it's going to print out values from 1 to 100. So that's just something that Python does, is it doesn't include the last value. So any questions about this for loop? How it's formatted, how it's working? Yeah, exactly. I is a dummy variable. It's kind of just how we define it. Awesome. So that's like a really quick overview of for loops. We'll do some demos with it later. But this, we're going to transition a little bit into while loops. So again, this is another kind of diagram of how your computer is reading while loops. So it's looking at your, what they call test expression. If it's false, it'll exit the loop. But if it's true, it'll run the statements inside. So again, here on the side, I show how it's formatted. We have while, and then whatever your value is true, colon, new line, tab, do something. So whatever you want your while loop to do. So that's just the general format of while loops. Some examples. Again, we're using this dummy variable here, just like a for loop. Printing the numbers 1 to 5. So first we have to define our variable. So let's just set I to 1. While I is less than 6, colon, new line, print I, and then we need to change the value of I, because otherwise I is not going to change, and we're just going to keep printing ones, which like isn't very helpful. Yeah, so it's basically going to keep running this statement until this condition, I is less than 6, is not true anymore. So if we look at the second statement down here, it's very, very similar, except we have the last two lines flipped. So we have the print line after the I plus equals to 1. And the output's going to be different. Does anyone have any ideas what'll change if we just flip these two lines? Remember the first example here, is printing the numbers 1 through 5. So this one's a little bit different. Yeah, and it's kind of tricky. So basically what's happening is this is going to print, instead of 1 to 5, it's going to print 1 to 6. Because it's changing this I value one last time before it's printing it. So just something to keep in mind, again, about ordering your code. Yeah, so that's kind of the basics of while loops. Does anyone have any questions about while loops, how they work, how they're formatted? Awesome. So now we have this example right here. We have while I equals 1, while I is less than 6, print I. Does anyone have any ideas what will happen if we run this example? Run this code in Python. Yeah, exactly, Derek. It'll just print ones forever. And that brings up a really excellent point about while loops, is that you need to be or you should be changing something within the while loop, because otherwise it'll just run forever. Because in this case, we're not changing the I variable. So I is always going to be less than 6. So it's just going to keep printing ones, which isn't super helpful and isn't super great for your computer. Yeah, so it's important to be changing, in this case, the I variable, so it's not an infinite loop. And this is just a funny little meme about the stuff we've talked about. Awesome. So this is the diagram again, about what while loops are. And then we have this on the side, and we're going to be doing an example with this. So it says, a wife calls her programmer husband and tells him, while you were out, buy some milk. He never returns home. So this kind of goes with the example that we just did, about a while loop never ending. So let's write some code that is that scenario, but it does end, because that's really important. So setting this variable out to true, setting milk to 0. Again, these are just things that we're making, variables that we're setting values to. And then using a while loop. So while out is equal to true, we're going to print buy milk. We're going to increase the value of, or increase milk by 1. And then we're using an if statement. So if milk is greater than 0, break. And what break means is it basically breaks out of the while loop. That's just something built into Python. And then we're going to print the programmer is back home. So this is kind of an example of putting an if statement inside of a while loop and also breaking out of a while loop so that they don't run infinitely. Any questions about this example? Awesome. Okay. So those are kind of all the basics that I wanted to go over with all of you. The basics of for loops, of while loops, of if statements. Now we're going to do a couple demos about how we kind of use these in practice. So let me open up Jupyter Notebook. Oops. Okay. Can we all see my screen? Just give me a thumbs up or whatever. Awesome, thanks. Okay, cool. So this first example that I'm going to show you guys is pretty simple, but I think it's kind of fun. So I'm going to create a list. I'm going to call it animals, because animals are cool. Does anyone have any animals they want me to add to my list? I'm going to do dog, maybe cat, crab. Anyone else have a favorite animal they want to put in this list? It can be literally anything. Let's see, we have a chat of something. Ooh, Perry the platypus. Okay, can I spell platypus? Platypus. Okay, cool. Cheetah, I like that. Cheetah. Bunny, love those guys. Eel, ooh, I like that. Okay, awesome. Snake, yes. Cool. I think it's a good amount of animals in my list. So yeah, I just made a list of strings. Oh, let's see, did someone else have another animal? Oh yes, all the important ones. So I just made a list of strings of animal names. Again, just like a recap, like lists can be like numbers or like integers or floats, or like in this case, strings. So I'm going to be writing a for loop and an if statement that will print out all the animal names that start with, let's say, the letter C. So what you do to accomplish this is I'm going to say for animals, animal in animals. Again, like animal is just a dummy variable. I could have said I could have said whatever I wanted, but these are animals, so I'll call it animal. For animal and animals, if animal, and then I want to check the first like character in each of the strings. So how we go about doing that is I'm going to do these brackets 0. So that's taking the first value of the string. If animal 0 is equal to, let's do C. Again, we need another colon, new line. Jupyter's nice and it already tabs for you. I'll just do print animal. So let's see if this works. Awesome. So as you can see, it ran through our whole list. And for each item in our list that starts with the C, it printed the animals that started with C. So I can change this to D, and we only have one animal, so that's the only one that gets printed. So yeah. Another cool example is, let's see, is kind of this die simulator. So how we can go about doing that is we need to import this package called random. So how you import a package again is just import and then whatever the package name is. So in this case, it's random. Yeah, okay, let's see. I have a question in the chat. Is 0 telling it to start checking the list at 0? Yeah, great question. So it's actually going to run through the entire list. So when you're doing a for loop, it's like always going to start like the first element. So like in this case, dog. What this 0 is basically telling us is that within each element, look at the first character. So like if I were to change this to 1, it's going to look at the second element for each, or the second character in each element of my list. So let's say I do O, it's going to return dog because it's the only value of my list where the second character is an O. Does that answer your question?
Yeah, it does. Thank you.
Okay, awesome. Yeah, it is a bit confusing. Yeah, and yeah, thanks, James. Strings are just like lists. They're indexed in a very similar way. So you can like call different characters of the string using the same bracket notation as you would for a list, which is kind of cool, I think. Okay, so now let's build that die simulator I was talking about. So we're going to import this package called random, which basically helps us create random numbers, which is kind of cool. We're just going to set these variables kind of at not super arbitrary, but kind of arbitrary values in the beginning, just because they need to be defined. We'll set value to 0 and guess to 1. So now what we're going to do is we're going to be writing a while loop. So while guess, where guess is defined right here, is not equal to value, where value is defined right here, we're going to write a colon and start a new line. So now we're writing stuff inside of our while loop. Guess is equal to int input. Then we're going to say, guess the value of the die. So basically what this is doing is saying that this value needs to be an integer. That's what this int does. And then input is basically something built into Python, which when I run it, it'll prompt you to input a value. So yeah. Then we're going to set value, and we're going to use that random package. Value equals random dot rand int. So this is just generating a random integer. And let's have it go from 1 to 6, like a die. So we're having our user input a guess, and then we're generating a random value. So now within this while statement, let's write an if statement that's going to check if our guess is the value. I see a question in the chat. Yeah, exactly. It's just an arbitrary guess. Something about kind of a different, something interesting about for loops and while loops is that like for for loops, we have this like random variable animal that we're using, but for while loops, we can't just like randomly say while guess isn't equal to value without saying what guess or value is. So it's important that that's defined beforehand, just like we did right here. But yeah, it's just an arbitrary value for now. So let's write that if statement. If guess is equal to the double equal signs, value, oops. Let's print, yay, you did it. Because you guessed the correct value. But if you didn't guess the correct value, we can write an else statement. So again, starting a new line that's in line with if, else, another print statement. Sorry, wrong value. So this is our die generator / guesser. So if we run it, let's see.
Gotta stop that cell because it was running from before.
Oh, good call, good call, good call. Yeah, also that's kind of an important point if you want to stop a kernel from running. Like let's say you did something silly like I did and it's just running forever. You can click this like square button right here and that'll interrupt the kernel. So that's kind of good to know. Yeah. So let's run this. Let's see, guess. I'll guess 3. It's the wrong value. I'll guess 2. I'll guess 1. I'll guess 1. Doing a poor job at guessing, apparently. And I pressed enter without actually clicking actually entering a value. So that's why the error occurred. But yeah, that's kind of how this die simulator works. Any questions on how this is structured or anything like this? Go try the lottery next. Yeah. Yeah, so these are just some fun examples that I wanted to show you all. But we have like 5 minutes left. I can go on and do another example, or if anyone has anything they want to see or anything they want me to recap, I can totally do that too. Okay, awesome. Let's see how far we get in another demo with with these 5 minutes remaining. Okay, cool. So now we're going to basically write this for loop, which is going to square values of a list and then append it to a new list. So let's create a list called numbers, and we'll just put some numbers in there. 1, 2, 3, 4, 5, 6, 7. Awesome. And then we're going to create an empty list. So we're going to be writing a for loop, which is going to square all the values. So let's make this list be called squared. And to make an empty list, it's just 2 brackets with nothing in it. Awesome. So now let's write that for loop. Let's use I. For I in numbers. So for each element in our numbers list, colon, new line, we're going to define this new variable square. Ooh, if I can spell, is equal to I, the element of our list. We want to square it, so we're going to use the 2 asterisks, 2. Then to add this value to our list, we do squares dot append square. So I know this is kind of new notation, but basically what this is doing is it's taking this square value and appending it. So it's adding it to the end of this list that we've defined up here. And then for fun, let's just print what square is, just so we can see it work. So if we run this, we get all the squares, 1 through 7. And then if we want to see the full list of all the values that we've squared, we can just call the list that we just made, called squared. And now we have a list with all of the values that we appended from that for loop. So does anyone have any questions about like lists or appending values to lists, or anything about this example? No, it's kind of new stuff. Cool. Well, if there are any questions that come up, feel free to let me know. Again, my office hours are right after this, so stick around. Before we all leave today, I want to make sure that everyone is able to open the homework, because that's due Wednesday. So make sure you can like open Jupyter Notebook, access the notebook file so that you can start working on that. Is anyone having any trouble with the notebook file? Yeah, how do we submit the homework? James, I believe it's just on B courses, correct?
There it is. Yeah, so what we're gonna do, we'll send an announcement out tomorrow just to be sure. But the way you submit the homework is you turn your notebook into a PDF file. You're gonna save it as a PDF and then submit it that way. And you're gonna run everything that you have. So you'll submit it as a PDF. That way we don't have to download your code, open up our Jupyter notebooks and run your code over again. That way you could just screenshot it, send it. We can just glance at it and look at it and give you points where it's needed. So in general, save it as a PDF. Isla, if you could share your screen really quick and show them how you could save a Jupyter notebook as a PDF, that would be greatly appreciated.
Yeah, for sure. Let me just share my desktop again. Yeah, so let's see. I believe it's, oh yeah. So on your Jupyter notebook, you can just go to File, Download As, And then there's an option down here that says PDF via latex.pdf.
Just a heads up that via LaTeX may not work. And if it does not work, either send me an email or you can fiddle around with other stuff. You can also try saving it as you can go to like I think it's like say or download as, or were you already at download as? Then save as, or no, you can go to file print. I think there's like a way to print it.
File print preview.
Yeah, print preview, and you could save it as a PDF that way. If it doesn't work the other way, I highly recommend the PDF via LaTeX. If you can get that to work, it makes it look very sexy. If not, it's fine. Just do this. This is kind of the workaround to that. But I'll send out an email or I'll send out an announcement just to make sure everybody has the written stuff down. So yeah.
I need help with accessing the homework in Jupyter Notebook.
Okay. I think you could stop recording now.
Okay, cool.